With this video, we will learn how to generate a cone, that is a surface of revolution, from an inclined line segment using Geogebra application. Now for this, we will define the line segment. The line segment has two ends, so the two ends, let them be O and A, where O is the origin and A is another point. So let us define this. O is equal to 0 0 0, so it will be in three dimension, so it will be 0 0 0, then we will put enter. So you can see that here at the origin O is already identified. Next we will set two parameters so that we can define A with a variable values. So we will define two values, one is r is equal to say 2, and h, that is here I am defining r as the radius of the cone to be generated, and height, that is the height of the cone. So here h is equal to say 5. Now we will define point A as in the polar coordinate it will be r theta z. So A is equal to r, then theta it may be say 0, and z, that is here it is h. So we can define that r, and you can see that below that it is calculating or representing that r0 and h to 2 0 and 5. So next enter. So you can see that point A is already identified in the space. So two points of the line segment O and A, these are the endpoints, so it is already identified. Now we will define the line segment with a command. Say the line segment function is defined as say f. So f is equal to segment, command we will use, so segment, then we will so segment has basically different arguments. So here we will use the argument, two arguments we will use, one is the first point, another is the last point. So first point is O, as we know, so it is O, and the second point is A as expected, and you can see that line segment is generated here, that is the black line segment, and it is showing its length as 5.39. Next we will put enter here so that it is confirmed. Next we will generate a surface which is obtained by rotating this line segment about the axis. So now we will define the axis here, axis as the z axis, so we will define that. So we will write axis colon, so axis is defined as the z axis, so axis colon axis colon z, z axis will be written like this, small z, then axis like this. So you can see that now the z axis is assigned to the axis variable, and you can see that the variable the axis is assigned the vector, so it is from 0 0 0 to 0 0 1, and has some magnitude lambda, so it is a variable lambda. Next we will just produce the surface. Let us give the name of the surface as say A. So A is equal to, we will give the command A is equal to, now the surface command is simply writing the surface, and surface will have basically three arguments. Among other variants of the surface function, we will use here the one with the function name. So function name is f, because the line segment is the function. Then the angle of rotation, say 360 degree, or pi, or say 2 pi, and then z axis is the axis of rotation, so we will write that z axis, and we will uh, put the enter, and you can see that that surface is basically generated. The surface of revolution, that is obtained by rotating the line segment about the z axis. Here it is a finite cone, so it is starting from point O and uh, going up to point A. So it is not an infinite cone, it is a finite cone, and you can see that point A is at the end of the circle, that is at the end of the circular base, and O is at the vertex. So it is a nice application you can use for generating such geometries using either tools or like using the equations.